Are you able to see my screen, Yuvika?
Yes, sir.
Awesome. First, we will do some fundamentals, Yuvika.
Yes.
Okay. We look at what is 1 mole of a compound, Yuvika.
Yes.
Yeah. So when I say 1 mole of any compound, let us say sulfuric acid, what would be the mass of this, Yuvika? For finding the mass of this, what we do is we calculate the molecular mass. All right.
Yeah.
So what is the molecular mass of sulfuric acid? How do we calculate?
So it'll be 2 into 1
Yeah, 2
plus
into 1
1
plus
plus
sulfur, the atomic mass is
32
32.
plus
Oxygen, the atomic mass is
60.
yes, Yuvika. And 4 atoms are there in a molecule.
Yes. So do we have to know a lot of these or like just the common ones should be?
Even if you know the first 20 elements, that should be good, Yuvika.
Okay.
Yeah. Till calcium.
Okay.
Yes, Yuvika. So that would be 64 plus 32, 96, 96 plus 2,
98.
98. So that's the molecular mass of sulfuric acid. When you express the molecular mass in grams, it is called 1 mole. So when I say 1 mole of sulfuric acid, how much does it weigh, Yuvika?
So 98 grams.
98 grams. That's all. Are you clear, Yuvika?
Yes.
Yes. That's the first thing. So you have to express your molecular mass in grams. That'll give you 1 mole, right?
Yes.
Okay. Now, suppose let's say I want to find out what is 1 mole of carbon dioxide gas. Let's say. First step is to find.
So the molecular
Molecular mass of carbon dioxide. So what would be the molecular mass, Yuvika? Carbon, the atomic mass is 12. Atomic mass of oxygen,
So 60.
yeah. 2 atoms are there.
16 into 2.
Would be 32, right, Viveka?
Yes, sir.
So what's the molecular mass of carbon dioxide?
44.
Yeah. So if I want to find out how much does it weigh?
44 grams.
Yes. So 1 mole of carbon dioxide weighs 44 grams, right? So this way, if you know the molecular formula, you can calculate the molecular mass. And when molecular mass is expressed in grams, that will be your 1 mole. Already, Vika?
Yeah.
Then accordingly, you can find n number of moles. For example, 2 moles would be how much? 2 moles of carbon dioxide would be?
So 2 into 44.
2 into 44, exactly, 88 grams.
Yes, sir.
Yes, Vika. So if I have to find out the number of moles, right, Vika?
Yes, sir.
So number of moles of any compound would be equal to given mass in grams divided by the molecular mass. Clear, Vika?
Yes.
For example, it's common, it's very simple. 44 grams of carbon dioxide is how many moles?
So 1.
1 mole. 88 grams would be?
2.
Exactly, Vika. So what do? You substitute the mass in the numerator. How much is given? divided by molecular mass. Clear?
Yes.
Yes. That's all. Now, let's look at another relationship, Viveka. So now we are looking at mole and mass, correct?
Yes.
Next, we look at mole and the number of molecules. Okay. One mole of any compound contains Avogadro number of molecules, Viveka.
Yes.
All right. We
Yes.
can represent by Na. What is the value of Avogadro number?
6 point
6.022 or 23 into
10 to the power
23.
20.
All right. So this will be the Avogadro number. Now, this we can calculate. I mean, how we get Avogadro number is very simple. We can use that PV equal to nRT gas equation and obtain. Okay.
Yes.
Yes. Viveka. So now, let's calculate the number of molecules for the examples that we have taken. The question could be like, I have 98 grams of sulfuric acid. How many moles is it? 1 mole, correct?
Yes. So 98 divided by 9.
Yeah, 98 divided by its molecular mass, 98. So that will be 1 mole, correct, Yuvika?
Yes.
Yeah. And we know that 1 mole has how many molecules?
So 6.023 into 10 to the power 23.
Yes, Yuvika. So 98 grams of sulfuric acid contains 6.022 or 023 into 10 power 23 molecules of sulfuric acid. Clear, Yuvika?
Yes.
Yes. Now, each molecule of sulfuric acid contains how many atoms of hydrogen?
So 2.
2 atoms. Each molecule of sulfuric acid contains how many atoms of sulfur?
1.
How many atoms of oxygen?
4.
4, right? Now,
Yes.
so if I ask you how many atoms of oxygen are available in 98 grams of sulfuric acid, what would be your answer?
So 4.
4 into Avogadro number, correct, Yuvika?
Yes.
98 grams of sulfuric acid has how many molecules of sulfuric acid?
4 into 6.023 into 10 to the power 20.
Yes, that will be the number of atoms of
Oxygen.
excellent. That's clear, Yuvika?
Yes.
And how many atoms of sulfur?
So what? Only 6.023.
Exactly. Only 6.023 10 power 23 atoms of sulfur. How many atoms of hydrogen?
So 2 into the.
Exactly. Perfect. So 2 into Avogadro number of atoms of hydrogen and 1 into Avogadro number of atoms of sulfur.
Oxygen.
Sulfur.
Sorry.
Clear, Viveka?
Yes.
Excellent. Now, this is very clear to you, right?
Yes.
Yes. Now let's look at the relationship of moles to volume at STP.
Yes.
One mole of any gas at STP at standard temperature and pressure occupies 22.4 liters, irrespective of what gas it is,
Yes, sir.
as long as it is 1 mole. For example, we were speaking of carbon dioxide, right?
Yes, sir.
So 1 mole of carbon dioxide, of course, it was nothing but 44 grams of carbon dioxide, correct, Yuvika?
Yes.
It was nothing but how many molecules would have been there? Because it is 1 mole. How many molecules would be there?
So 6.023 into 10 to the power 23 into 4.
Why 4, Yuvika?
No, sir. I was going to say 44, but then I realized it was 2.
No, 40, that is a separate thing, right?
Yes, sir. Because it's only 1 mole.
Yeah, 1 mole. 1 mole weighs 44 grams. 1 mole contains.
Yes.
Right, Yuvika?
Yes.
1 mole of carbon dioxide gas contains Avogadro number of molecules.
Mole.
How many atoms of carbon?
So it will contain 1 into 6.023 into 10 to the power 23.
Atoms of carbon. Excellent. And how many atoms of oxygen?
So 2 into 6.023 into 10 to the power 23.
Atoms of oxygen. Fantastic, Yuvika, right? Now, 1 mole of carbon dioxide at STP occupies 22.4 liters.
Yes.
Clear, Yuvika?
Yes.
Usually, these are the three relationships which we need to know.
Yes.
And everything is proportional, which means 1 mole occupies 22.4 liters, right?
Yes.
2 moles will occupy 44.8.
Okay. Yes.
Half mole will occupy 11.2.
Yes.
Are you able to understand, Yuvika?
Yes, sir. Yes.
Awesome. Great. Now let's look at a few important terms. Any doubts in this so far?
No, sir. It's clear.
Now let's look at a few terms here, few concentration terms. We talk about something called molarity, right, Yuvika?
Yes.
What is molarity? Molarity is nothing but the number of moles of a solute
Yes, sir.
which is going to be present in 1 liter of the solution.
Yes.
All right, Vika. So it refers to number of moles of the solute.
Per liter of the solution.
Sorry, Vika.
So for 1 liter.
Yes, present in 1 liter of the solution. Clear, Vika? When I
Yes,
say
sir.
solution, it's the solute plus the solvent.
Yes, sir.
Right, Vika? So
Yes, sir.
suppose if I have to prepare 1 molar solution of sulfuric acid, how would we do it?
So
Take
we
Vika. Tell me, Vika.
so we
1
have
mole of
to
sodium hydroxide we want to prepare.
sorry.
1 molar solution of
So we'll have to add 1.
already, Vika.
Yes, sir.
So now, if I have to prepare 1 molar solution of sodium hydroxide, first thing I should know what is its molecular mass, right?
Yes, sir.
So what is the molecular mass of sodium hydroxide?
So 35.
Sodium. What is the atomic mass, Vika?
So 35.
23.
Oh, sorry, sir. That's close.
Atomic mass is 23 for sodium. For oxygen, it is
16 plus 1.
1, right, Viveka? So the
Yes.
molecular mass of sodium hydroxide would be 39 plus 1, 40. Okay, Viveka?
Yes, sir.
So now we have with us molecular mass of sodium hydroxide. Now, how much is 1 mole of sodium hydroxide? What is the weight of 1 mole of sodium hydroxide?
So 40.
40?
40 grams.
40 grams, exactly, Viveka. So 1 mole of sodium hydroxide weighs 40 gram. So what would I do? I will measure 40 grams of sodium hydroxide.
And put it in this.
Yeah, put it in the beaker, right?
Yes.
Clear, Viveka?
Yes, sir.
Then what will I do? I will start adding water until the total volume is what?
1 liter.
1 liter along with sodium hydroxide. Are you clear with this?
Yes, sir.
This total volume is 1 liter. Now I can say the solution is what? 1 molar solution.
Yes.
Suppose if I have, instead of 40 grams, if I have 80 grams of sodium hydroxide, together with sodium hydroxide, the solution volume is 1 liter.
It will be 2.
Fantastic. It will be 2 molar. Clear, Viveka?
Yes, sir.
Suppose instead of 80 grams, if I have 20 grams of sodium hydroxide,
Instead of, sorry, sir.
tell me, Viveka. So,
So
total mass of sodium hydroxide is 40 gram, 40, right?
instead of 40, you have?
When you put 40 grams of sodium hydroxide and make it up to 1 liter with water, then
Yes.
it's a 1 molar solution, correct?
Yes, sir.
If I have 20 grams only, not 40 grams, but 20 grams only,
Yes, sir.
then what molar solution would it be? I make it up to 1 liter,
Half.
half. Are you clear, Viveka?
Yes, sir.
That's all. So, if you want to go by a formula for this, then I can say molarity, if you want to find, is nothing but number of moles of the solute divided by volume of the
Solution in
solution in liters. Clear, Viveka?
Yes, sir.
For example, if I have 40 grams of sodium hydroxide in 1 liter of the solution, it is 1 molar, correct?
Yes, sir.
Suppose if I have 40 grams of sodium hydroxide in half liter, then it will be 2 molar. I repeat, 40 grams sodium hydroxide in 1 liter of the solution is what?
1 molar.
1 liter. Yeah, 1 molar solution. Correct, Viveka?
Yes, sir.
I have 40 grams in half a liter of the solution. So 40 grams in half a liter means in 1 liter, how much would it be?
So 20 grams.
No. Half a liter, 40 grams. Then 1 liter, double, right?
80, sir.
80 grams. So then 80 grams corresponds to how many moles?
2 moles.
So it's 2 molar solution. Correct, Viveka?
Yes, sir.
Yeah. But if you do not want to do this proportionality in thinking, you can directly use the formula. Number of moles. For example, I have 40 grams in half liter. So what do you do? 40 grams of sodium hydroxide I have. Number of moles, how do I find?
So you use mass in grams by molecular mass.
Fantastic. So I have 40 grams of sodium hydroxide. What is the molecular mass of sodium hydroxide?
So we got 40.
40 by 40 is?
1, sir.
So number of moles is 1. Volume of the solution is how much?
So 1.
1 by 2. I told half liter.
Oh, sorry, sir. Half liter.
So when you say half, then numerator is 1, denominator is half, correct?
Yes, sir. It will become 2.
That's it. So are you able to understand, Yuvika?
Yes, sir.
This is called molarity. Okay.
Yeah.
Now let's look at another one which is called molality. Okay, molarity of a solution. A solution would be said to be 1 molal. All right, Vika. There you say molar.
Yes.
That is
Yes.
molarity. This is what?
Molality.
Molality. Okay. A solution is said to be 1 molal if there is 1 mole of the solute dissolved in
1 kg of solution.
dissolved in 1 kg of not the solution but the
Solvent.
solvent.
Yes.
Is it clear, Vika?
Yes.
So suppose if I ask you to prepare 1 molal solution of sodium hydroxide, right, Vika?
Yes, sir.
So what would I do?
So you take 40
Huh?
grams.
Yes, very good, Vika. So 1 mole of sodium hydroxide you're going to prepare. You're going to take. So how much is 1 mole of sodium hydroxide?
So 40 grams.
Yeah, you're going to weigh 40 grams and you're going to add it here to the beaker. Then you're going to add water. How much of the water are you going to add?
So 1 kg.
Exactly. So you will measure 1 kg of water and you will add it. Are you clear, Vika?
Yes, sir.
What would be the mass of the mixture?
So 100 plus 40.
1 kg plus 40 grams. Clear, Vika?
Sorry, so 1 kg.
1000 gram plus 40 grams. Already, Vika?
Yes.
Yes. So this way you prepare 1 molal solution. Is it clear, Vika?
Yes, sir.
So if you want to go by, so first I'll tell you by the proportionality. So if I have 40 grams of sodium hydroxide dissolved in 1 kg of water, then it is 1 molal solution, correct?
Yes, sir.
If I have 80 grams of sodium hydroxide,
Yes, sir.
2 molal solution, correct, Vika?
Yes, sir. 2.
If I have 20 grams of sodium hydroxide,
So half.
half molal solution, right, Vika? Okay.
Yes.
So how do you define molality?
So number of moles of the solute by mass of the solvent in kg.
Excellent. Perfect, Vika. Mass of solvent in kilograms, right, Vika?
Yes.
So when you know the formula, there is not much to think. You can directly plug it in and get the answer, right, Vika?
Yes.
Is this clear to you?
Yes, sir.
Awesome. So now let's do a few questions so that these concepts are kind of revised, right?
Yes.
Okay. All right, let's look at the first question. How many electrons are present in 1.6 grams of methane? Right, Vika?
Yes.
First, we look at the molecular formula for methane.
So it is
So, methane is nothing but
CH4.
CH4. Perfect. Now, next thing is to find the molecular mass. Atomic mass of carbon is 12.
12, 12 plus 16 into 4.
Yes, you
Oh,
did.
sorry, sir. 12 plus 4.
So, what would be the answer? 16. Correct, Vika?
Yes.
So, when I say 1 mole of methane,
It has 16.
yes, Vika, it weighs 16 grams. correct?
Yes, sir.
And how many molecules will it contain?
So 1 second.
Yes.
Sorry, sir. Someone
No
just.
problem, Viveka. Is it clear, Viveka, so far?
Yes, sir. Yes.
Yeah. So 1 mole of methane weighs
16 grams.
16 grams, right, Viveka? Now,
Yes.
how many molecules does it contain, Viveka?
So it contains 6.023
Yes.
into 10 power 22
6.022 or 23 into 10 power 23
mole.
molecules of methane. Clear, Viveka?
Yes.
Yes. So this is what will be the number of molecules. Now, how many atoms of carbon? How many atoms of carbon, Viveka?
So it contains 1 into 6.02.
Excellent, Viveka. So it contains 6.023 into 10 power 23 atoms of carbon. Correct.
Yes.
How many atoms of hydrogen, Viveka?
So 4 into so
Yeah. Into 4, right? Because each molecule has 4 atoms, therefore,
yes, 4 into 6.02.
yes, atoms of hydrogen. Correct, Viveka?
Yes.
Now, if I give you an atom, uh, on what basis would you find the number of electrons in it, Viveka? Atomic number.
So I didn't get you, sir.
Sorry, Viveka.
So I didn't understand what you said.
Okay. So if I give you an if I give you an element, if I give you an element or an atom, right? I want you to find how many electrons are present in that. On what basis would you decide on the number of electrons present? It is based on
Atomic
atomic number. What is the definition of atomic number? It is equal to the
number of protons
protons
plus
in the nucleus, or it is also equal to what?
number of electrons.
Which are revolving around. Correct, Viveka?
Yes.
In a neutral atom. So now, how many atoms are there in 1 mole of methane?
So how
How many
so
atoms are there in 1 mole of methane? 6.023 into 10 power 20
20.
atoms of carbon, correct?
Yes.
One carbon. So what is the atomic number of carbon? Atomic mass we understood is 12, right?
Yes.
Atomic number is 6. All right, Viveka?
So atom. Oh, sorry. So atomic number.
Yeah. Atomic number for carbon is 6. Atomic number for hydrogen is 1. All right, Viveka?
Yes.
Which means each carbon atom has how many electrons, Viveka?
So it has 6.
6. Each atom of carbon has 6 electrons. Correct, Viveka?
Yes.
Each atom of hydrogen has how many electrons?
1. Sir.
Yes. Each atom of carbon, 6 electrons are there. Each atom of hydrogen,
1. Sir.
1 electron is there. So now can you tell me, if I give you 1 mole of methane, how many electrons will be there?
So 7.
I'm sorry, Viveka.
Sorry, sir. 7.
Methane is CH4, correct?
It will be 10, sir.
Yeah. So one molecule will have how much?
So 10.
Yes. One molecule of methane has how many electrons, Viveka?
Okay.
6 plus what? 4.
4.
How many?
10, sir.
10 electrons is in one molecule. But how many molecules are there?
6.023 into 10 to the power.
6.023 into 10 power 23 molecules are there. So how many electrons will be there? Tell me, Yuvika.
So that into
That into
tens.
perfect. So it will be 6.02 into 10 power
20.
54 electrons will be there. In how many grams of methane, Yuvika?
16. Sir.
So in 16 grams, we will have 6.023 into 10 power 24 electrons, correct?
Yes.
Any doubts in this, Yuvika?
No, sir.
Okay. But how many grams do we have in our question?
1.6.
Which is 1/10, correct?
Yes.
So how many electrons do you expect to be there?
It's a 6.023 into 20.
10 power
20.
23. Perfect, Yuvika. So which option is correct?
So option
Yes. Are you clear with this, Yuvika?
A. Yes. Sir.
Yeah, just make a note of what is necessary. Then we'll go to the next question. Alright, Yuvika. Let's go to the next question now. Are you
Yes.
able to see it?
Yes, sir.
Yes. KClO3 on heating decomposes to give KCl and O2, right?
Yes, sir.
Is it balanced, Yuvika?
No, sir.
No, right? Here there are two oxygen atoms, whereas in the reactant, three oxygen atoms are there, right?
Yes, sir.
So what do I do? Is it balanced now?
Yes.
Yes, Yuvika. Six oxygen atoms, two potassium and two chlorine. Clear, Yuvika?
Yes. Yes.
Yes. Now what is given in the question? Find the volume of oxygen that is liberated at STP by how many moles?
0.1.
Yes. Now, just look at the relationship. 2 moles of KClO3 provides how many moles of potassium chloride and how many moles of oxygen?
Sir, 2 moles of KCl and 3 moles of oxygen.
3 moles of oxygen, correct?
Yes.
Yeah. So this relationship is important for us. So 2 moles of KClO3 liberates or provides how many moles of oxygen, Yuvika?
So 3.
Yeah, 3 moles of oxygen gas. Right, Yuvika?
Yes.
In such a case, 1 mole of KClO3 will provide 2 moles provides 3 moles of oxygen, correct?
Yes, sir.
1 mole will provide how much, Yuvika?
So 3 by 2.
Excellent. So 1 mole will provide 1 mole of KClO3 will provide 3 by 2 moles of oxygen gas. Clear, Yuvika?
Yes, sir.
But we don't want 1 mole. How much do we want?
So we want 0.1.
0.1. 0.1 is what, Yuvika? Can I write it as
So
1 by 10?
yes, sir.
So 1 by 10th of a mole of KClO3 shall provide
So 3 by 2 by 10.
fantastic Vika. 3 by 2 by 10. So that will be nothing but 3 by 20 moles of oxygen gas. Clear, Vika?
Yes, sir.
Now this is our important number. Now our focus can come to only oxygen gas. Clear?
Yes, sir.
Yeah. So now let's look at this. So far, any doubts, Vika?
No, sir.
Okay. Now, We know that, so this part is complete. We know that 1 mole of oxygen gas at STP will occupy how much volume, Viveka?
So 22.4.
Yes, exactly. 22.4 liters. Now, how many moles of oxygen gas are with us?
So 2 by 20.
Yes. 3 by 20th of a mole of oxygen gas will occupy how much, Viveka? 1 mole occupies 22.4 liters. So 3 by 20 of mole will occupy.
So we have to cross multiply.
You have to just multiply. Say 1 mole of oxygen has 22.4 liters. How much will 2 moles have, Viveka?
So 2 into 20.
2 in 22. How much about, what about 4 moles? 4 in
4.
22. 3 by 20th of a mole.
So 3 by 20 into 22.
Exactly, Viveka. Are you clear, Viveka?
Yes.
Yes. Of course, we know 22.4 divided by 10 is what? 2.24.
Yes.
2.24 divided by 2 is 11.2.
Yes.
3 into 11.2 would be,
33 points.
yeah, divided by 10. I repeat again. 22.4 divided by 10 is 2.24, right?
Yes.
2.24 divided by 2 is,
Divided by 2 is 1.1.
yeah, 3 into 1.12 is,
So we did 11 into.
sorry, Viveka.
So previous time we did 11 in 11.2.
Yeah, we didn't divide that 10.
Okay, sir.
Yes, Viveka. So it's 1.12 into 3. So what do you get?
So 3.3.
So which option is correct?
Option B.
Is it clear, Viveka, how you approach?
Yes, sir.
Yeah, just go through it once. Let me know if you have any doubts. Once you've taken down, we'll go to the next question. Yes, Viveka. At STP, the density of carbon tetrachloride vapor in gram per liter will be nearest to. So what is the formula for density, Viveka?
So mass by volume.
Yes. So what we can find first?
So mass.
Molecular mass, Viveka?
Oh, yes, sir.
Yes, Viveka. So molecular mass of carbon tetrachloride. Carbon, what is the atomic mass? 12.
That's 12.
For chlorine, the atomic mass is 35.5, Viveka.
Yes.
But how many atoms of chlorine are there?
2, sir.
4. CCl 4, right?
Yes.
So this will be 12 plus 35.5 into 2 is 71, right?
Yes, sir.
71 into 2 will be 140.
142.
Yes. So what will be the total molecular mass?
So 12 plus
Yeah.
142.
154, Viveka?
154.
Yes. Now how much is 1 mole of CCl 4, Viveka?
So 154 grams.
Fantastic. 154 grams. Now we don't know about other masses, but if it's 1 mole of any substance at STP, it will occupy.
So 22.4.
Yes. So for 154 grams of CCl4 will occupy how much volume, Viveka?
So 154 into 22.
No, listen, Viveka. 154 grams of 1 mole of CCl4 will occupy how much volume?
So 22.4.
That's all. 154 grams is nothing but 1 mole.
Oh, yes.
So 154 grams of CCl4 will occupy?
22.4.
Yes. So we know the mass, we know the volume. So what is the mass?
Also 154.
What is the volume, Viveka?
22.4.
22 point?
4 liter.
Right, Viveka? If I divide by 2, I'll get 71. Here I'll get 11.2.
Yes, sir.
Yes, Viveka?
Yes, sir.
See, 11 into 6 is 66, correct?
Yes, sir.
11 into 7 is 77.
Yes, sir.
So answer must be between 6 and 7.
Yes, sir.
Yeah, so which option?
6.8.
Did you understand, Viveka?
Yes, sir.
Yeah, you can take it down. Okay, now let's go to the next question. Question number 4. .4 gram of an unknown gas occupies 2.24 liters of volume at NTP or STP. The gas may be carbon dioxide, carbon monoxide, oxygen, or sulfur dioxide. Right, Yuvika?
Yes.
So the gas is occupying how? What is the mass of the gas?
4.4 grams.
4.4 gram occupies how much volume?
2.24 liter.
So, how much will be the mass which occupies 22.4 liters, Yuvika?
So we'll get 22.4 into 4.4 divided by 2.
So, what is it going to be?
So 44.
Yes, Yuvika. See, it's straightforward. We don't need to calculate separately. See here, 4.4 gram corresponds to 22.24 liters.
Oh, yes, sir. Just the
When I'm saying 22.4, I'm just multiplying by 10, right?
by 10. Yes.
So here also I can multiply by 10. Is it clear?
Yes, sir. Yes.
So 44 grams of the gas occupies how much?
22.4 liters.
Correct, Viveka?
Yes, sir.
Now we know something very well. What is it? How many moles occupies 22.4 liters? How many moles of a gas?
1, sir.
1 mole of a gas. Then this must correspond to 1 mole of the gas.
That will be carbon dioxide.
Fantastic. That's all. Very good. So 1 mole of a gas corresponds to 44 grams, which means this number 44 must be
Corresponding to 1
molecular mass. That number 44 must be corresponding to what?
molecular mass.
Molecular mass of the gas. And we very well know that carbon dioxide's molecular mass is what?
44.
Yes, right? Therefore, the answer is
Carbon dioxide.
yes, Viveka. So if the gas is carbon dioxide, what is the molecular mass?
44 grams.
Suppose if it is carbon monoxide, what will be the molecular mass? Carbon atomic mass is 12, oxygen is 16, right?
Yes, sir.
12 plus 16, how much?
30. No, sir. 28.
28, yes, Viveka. Oxygen, when I say oxygen, it's oxygen gas, which means O2.
Yes, sir.
16 into 2, how much?
32.
32. When I say sulfur dioxide, it is SO2. Sulfur, what is atomic mass? 32. Two oxygen atoms, 16 into 2, 32. 32 plus 32,
So 64.
therefore, these would be the corresponding molecular masses.
Yes.
And in this question, it's clear that 44 is the molecular mass of carbon dioxide, therefore, that's going to be the answer. Clear, Yuvika?
Yes.
Any doubts on this?
No, sir.
Awesome. Now let's move on to the next question. Question number 5. Okay. Mass of carbon that is present in 0.5 mole of potassium ferrocyanide is already bigger.
Yes.
Okay. Now you don't have to know the complete molecular mass of the substance at all.
Okay.
Okay, Vika. See here, when I say 1 mole of potassium ferrocyanide, FeCN6, contains how many carbon atoms, Vika? Or you can say one molecule contains how many carbon atoms?
6.
6, correct?
Yes.
1 mole would contain how much weight of carbon atoms?
How much weight?
Yes, Vika. Yeah, suppose, let me ask you this way. You will understand better. Carbon dioxide we calculated, right?
Yes.
1 mole of carbon dioxide, what was the weight of it?
So 44.
44 grams. So my other question is, 1 mole of carbon dioxide has what mass of carbon in it?
So 44.
44 grams is the mass of, is 1 mole of carbon dioxide, CO2.
Yes. Sir.
Oxygen will contribute how much? 16 into 2, 32 grams.
So it will be 12 grams.
12 grams. So 1 mole of carbon dioxide add how much?
So 12 grams.
12 grams of carbon. How many grams of oxygen?
So 32.
32 grams. How did you get 32?
So 16.
16 into 2. Understood or not?
Yes, sir.
Now, just by looking at this, can you tell me how much mass of carbon will be there in this?
So 12 into 6.
12 into?
6.
Exactly. 12 into 6?
92.
72, right?
Yes.
72?
Grams.
Yes. Are you clear, Vivek?
Yes.
Now, what is asked here?
So 0.5.
0.5. 0.5 is how much?
So 1 by 2.
Yeah. So 1 by 2 mole of potassium ferrocyanide will have how many grams of carbon, Vivek?
So 36.
Exactly. Half of this. Correct, Vivek?
Yes.
So what is the right answer?
36.
Fourth option. Are you clear?
Yes.
So we did not have to find out the molecular mass of the total substance. Clear?
Yes.
Yes. You can make a note of it, Yuvika.
Yes. Sir.
Clear?
Yes. Sir.
Excellent. Shall we move on to the next question?
Yes.
61. The number of moles of barium carbonate which contains 1.5 moles of oxygen atoms is. Okay.
Yes.
Now again, we don't need to find out the molecular mass of barium carbonate for this.
Yes, okay.
Clear, Viveka?
Okay, sir.
Now tell me, let's go back to the question we did on, I was just giving you the basics of sulfuric acid, right?
Yes, sir.
Go back there. Yeah. Or even here, that should be good. Are you able to see the screen, Viveka?
Yes, sir.
Yeah. So 1 mole of methane contained how many atoms of carbon, Viveka?
So 6.023 into 10 to the power 20.
Yes, Yuvika. So I could alternately call it as 1 mole of methane contains 1 mole of carbon atoms.
Okay.
Or I could call it alternatively. Instead of giving that number, I can say 1 mole of carbon atoms. Okay.
Yes, sir.
1 mole of methane contains, can you tell in the same terminology how you call for hydrogen?
So 1 mole of methane contains 1 mole of 4 moles of hydrogen atom.
Yes. So 1 mole of methane contains 1 mole of carbon atoms. 1 mole of methane contains
4 moles of
hydrogen atoms. Are you clear, Yuvika?
yes.
Okay, now this will come in handy for solving this question now. Okay, now we'll come back to this question. 1 mole of barium carbonate contains, can you tell me how many moles of oxygen atoms?
3, sir.
Fantastic. Is this clear, Yuvika?
Yes.
So the question is, how many moles of barium carbonate shall contain how much?
So 1.5.
1.5 moles of oxygen atoms. What do you expect, Yuvika?
So 1 by 2.
1 by 2. Is that? 0.5. So 0.5 moles of barium carbonate will contain 1.5 moles of oxygen atoms.
Yes.
Clear, Viveka?
Yes.
Excellent. You note it down?
Yes.
Yeah. We'll go to the next question. Question number 7. All right. What is the volume of oxygen required at STP in order to burn 30 ml of acetylene at STP? Right, Viveka?
Yes.
So for this, we need to know the molecular formula and molecular mass of acetylene, right?
Yes.
And we need to know what happens when you burn acetylene with oxygen. Correct, Viveka?
Yes, sir.
Then we need to write the balanced chemical equation and then we can start our analysis, right?
Okay.
So acetylene is a hydrocarbon, right, Yuvika?
Yes.
And any hydrocarbon, if you burn in oxygen, the products are constants. There are only two products, okay, Yuvika?
Okay.
Whether you burn methane in oxygen, whether you burn ethane in oxygen, ethene in oxygen, ethine in oxygen, doesn't matter. All
Yes.
of them, when they burn in oxygen, they give you only two products, carbon dioxide and water.
Yes.
So now acetylene. What is acetylene? Acetylene is also called ethine.
Ethyl.
It's a triple bonded hydrocarbon, correct?
Yes, sir.
So what is the
Yes.
molecular formula?
C2H.
C2H2.
H.
This is called acetylene. Or we call it as
Ethyl.
ethine. Yeah. Okay. Now, when you are going to burn it in oxygen, products are well known to us. So you need not expect the products to be given in the question. We will know it. So what are the products?
So I can't see your screen.
You can't see my screen, Yuvika. Once.
Yes. So I think my internet is lagging. Can I just leave and join again?
Yeah, please. Okay. So as I told you, acetylene, when it's burnt in oxygen, the products will be
CO2 and H2.
H2. So our next step is to balance the chemical equation.
Yes.
So hydrogen atoms, 2 are there, no problem. Carbon atoms,
So we need to.
balance them, right? So we need to, here it's 2. So I can presently place a 2 here, correct?
Yes.
Yeah. So now carbon is balanced. Hydrogen atoms are balanced, correct?
Yes, sir. Only
How many
oxygen.
oxygen atoms do we have?
5, sir.
5 oxygen atoms. So how many oxygen, what do I multiply with?
2 and
2.5, correct?
yes, sir.
2.5. 2.5 into 2 becomes 5.
Yes.
Yeah, if I do not want to have a fraction, I can multiply by 2 throughout, correct?
Yes, sir.
So what would this become, Yuvika?
So can we leave it as fractions or do we have to have?
I'm sorry, Yuvika.
So can we leave it as fractions or do we have to?
No, we can leave it as fractions, no problem. So now what's the, so even if you write it as 2.5, it's fine.
Yes.
Okay, Vika. Now you can see 2 into 2 is 4, 4 carbon atoms. 2 into 2, 4 hydrogen is also 4. Totally, how many oxygen atoms do we have on the right? 4 into
10.
8 plus 2, 10. 5 into 2, 10. Clear, Vika?
Yes.
It's a balanced chemical equation. Now we can do our analysis, right? So what is asked?
Yes.
Volume of oxygen required to completely burn 30 ml of acetylene at STP. Clear?
Yes.
Okay. Now 2 moles of acetylene combines with how many moles of oxygen, Yuvika?
So 5.
5 moles, correct?
Yes, sir.
So I can say 2 volumes of acetylene combines with how many volumes of oxygen?
5, sir.
5 volumes, because I can connect it that way, because mole corresponds to 22.4 liters at STP, correct?
Yes, sir.
So if you see 2 into 22.4 liters of acetylene will combine with what? 5 into
5
22.4 liters of oxygen.
oxygen. Yes, sir.
I can divide by 22.4. So 2 liters of acetylene will combine with how many liters of oxygen?
5, sir.
5 liters. Are you clear, Viveka?
Yes, sir.
Yeah. Now we want ml, so let's do it in ml. So 2 ml. So 2 ml of acetylene will combine with how many mLs of oxygen?
5, sir.
5 ml of oxygen. Correct, Viveka?
Yes.
Right. Or in other words, 5 ml of oxygen is required to completely burn how many mLs of.
2 ml.
Okay. Now tell me, directly also we could do. For 2 ml of acetylene, it requires 5 ml of oxygen, correct?
Yes, sir.
But how much do we need to burn here?
30
30
ml.
ml. So for burning 30 ml of acetylene, I require how much ml of oxygen?
So it will be 30 into 5 divided by 2.
Yeah, how much would it be?
75.
70. That's it. Understood, Yuvika?
Yes, sir.
Directly, if you observe here, what is the multiplying factor here? 2 into 15 is 30, right?
Yes, sir.
So here also the same multiplying factor will apply. 5 into 15 will be your answer, correct?
Yes, sir.
Yes. So from the balanced chemical equation, directly you can establish a volume relationship.
Yes.
Clear, Viveka?
Yes.
Yes. So any doubts in what we discussed today?
sir.
Very good. I'll do one thing. I shall send you this worksheet. Would you like to attempt it, Yuvika?
Yes, sir.
Because now the concepts are clear. Yes?
Yes, sir.
All right, Yuvika. All the best, Yuvika. Take care.
Thank you.
Sure, Yuvika.